Hi, I'm Carolyn Stellmacher. I will talk about how to provide users with haptic feedback by augmenting the trigger with adaptive resistance. I'm a PhD student from Germany at the University of Bremen, and this talk is for the IEEE VR workshop on novel input devices and interaction techniques. Commercial VR controllers offer many components to register user input, such as buttons or triggers. They allow different techniques for users to interact with the virtual environment. However, to experience a haptic response during the interaction, only vibroprotector rendering is offered by commercial VR controllers. On the one hand, this forbids users an inappropriate haptic experience, and on the other hand, it forbids haptic feedback that is specific to a particular user input. For example, grabbing a light virtual object by pulling the trigger feels identical to grabbing a heavy virtual object. And so the perception of the virtual weight is missing. Weight is particularly challenging to simulate with mobile VR controllers since no external forces can be generated. To provide a haptic sensation of weight with mobile VR devices, different mechanics were investigated through asymmetric vibrations or movable plates to create skin deformation at users' finger pads. By changing the weight distribution of the device or by changing the actual weight of the device by moving fluids. However, these can be very specific to a use case or they need to be adjustable for different hand sizes. We wanted to find a solution to simulate weight in VR that can be more versatile and more accessible to users in the commercial domain. Our solution? We augmented the trigger with resistive force, and we built our working prototype called Trigger Muscle. Trigger Muscle adapts the resistance of the trigger according to the weight of the grabbed virtual object. The concept is based on how humans perceive weight in reality. When we lift an object, we modulate our grip forces according to that weight, and trigger muscle simulates those grip forces through the resistance. To change the resistance, our mechanism uses an extension spring that is connected to the original trigger on one end and to a servo motor on the other end. The servo then pulls or releases the spring, which changes the exerted resistive force of the spring. This process happens dynamically and on a continuous range. And with our used spring model, trigger muscle renders a resistance between around 4 to 16 newtons. To build our prototype, we used an empty casing of an HTC Vive controller, and we built the spring mechanism into the casing. We used inexpensive hardware, and the implementation can be easily tailored to other form factors. So let's take a look at how trigger muscle simulates 3 virtual fruits with different weights. First, the lowest resistance is set for the virtual strawberry. Moving on to the apple, the servo pulls the string to set a medium resistance. And moving on to the pineapple, trigger muscle sets the highest resistance. The servo is controlled by a microcontroller unit which communicates with Unity via Bluetooth, and it is carried in a small bag alongside the battery. With this work, we explored a new approach to extend an established income component with haptic feedback. We hope that our work motivates further research in haptic feedback that is specific to particular interaction technique. And with this, we hope to shift the perspective from VR input devices more towards input-output devices. Thank you.